I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will see how do we evaluate limits. I have 12 questions for you to practice. We'll begin with simple questions where substitution can help us evaluate the limits. And then we'll look into indeterminants and how do we solve when you get 0 by 0 or infinity minus infinity. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Akshit. Hi Akshit, how are you doing?
I'm doing good, sir. How are you?
Very good. So today, what do you want to do?
Sir, I think today we can continue practicing limits and expand upon it.
Sure. So when is your class starting on this?
My class on limits is actually starting Monday. Right
Monday.
now, we're just covering prerequisite knowledge.
Okay, great. So you're slightly ahead. That's very good. So
Yeah.
stay ahead. So let me share with you the lesson which I have prepared. We
Yeah.
already talked about limits. Here, we have some practice questions for you. Okay, so today we are only going to practice. Let
Okay.
us see how to solve these examples. So we have around 12 questions for you here. Question number 1. Can you see my screen?
Yes, sir. I can see it. Perfect.
Okay, so can you please answer this question? Limit x cube minus 2x square plus 4x minus 8 divided by x square minus 4x plus 4,
Yes,
where
sir.
x approaches minus 2. What will you do?
First, I would take -2 and plug it in as x, and then evaluate the limits.
Correct. So when you plug in minus 2, in this case, what do you get? Can you just try it out?
Yes, sir. So -8, and then -8, -8 again.
Yeah, do it on paper. It'd be better, right?
Yes, sir.
So basically, for question number 1, just substitute minus 2 first.
Yeah.
Because if the function is continuous at minus 2, you'll get a value, and that will be the limit of the function, correct?
Right.
However, if you get undefined, then you know there is a factor in the denominator for minus 2, right? But
Yeah.
it is not, because denominator is x squared minus 4x. It is x plus 2 whole square, right? Do we have
Yeah.
a factor there?
No, sir, we don't.
This could be expanded as x minus 2 whole square. When you plug in minus 2, you get actually minus 4, right?
Yeah, -4. Yeah.
So this is continuous at minus 4. So substitute minus 2 and get the answer, correct?
Yeah.
Perfect. So whatever you get, that'll be your answer. And this is direct substitution. So I've done the calculation for you here. Uh, so do you get the value?
Sir, actually, for some reason, my calculator isn't outputting it properly.
Okay. So let me just share with you this answer of this direct substitution. So when I substitute minus 2 here, what I get after simplifying and calculating, minus 2. So that
Yeah.
is the limit of the function. You note that the denominator is x minus 2 whole square. So it has a vertical asymptote at x equals to plus 2. Do you see that?
+2. Yeah.
Not as minus 2, correct?
Yeah.
Now let me change this question. Let's find the limit of this function when x approaches plus 2. Then what will happen? Tell me.
When x approaches +2, right, sir?
Yeah.
I think
So
since
we have
it's
the factored form as x minus 2 times x squared plus 4 over
yeah.
x minus 2. Yeah. How will you find that?
Well, sir, without any plugging in or anything, I can see that the vertical asymptote's at x equals positive 2, right? So when it approaches like a very infinite value. So I think the limit wouldn't exist, right?
No. So when you plug in 2, you will get a form 0 over 0. Do you see that?
Oh, yeah, the
Now 0 over
indeterminate form, right?
is indeterminate.
Yeah.
In that case, you will adopt the technique of factoring.
Okay.
So when you factor, you will get x minus 2 as a common factor, correct? As you
Yeah.
can see. Then you can cancel this. And now this is equals to limit x approaches 2 for x squared plus 4, right? Now you can substitute 2 here and you get 2 squared plus 4, which is 4 plus 4, which is 8. You see that?
Yes, sir.
So limit of this function exists at
Okay.
x equals to 2 as x approaches 2 since
Yeah.
we have a common factor in numerator and denominator, which actually cancels. So it does not have a vertical asymptote. It says a whole
Oh, okay. Because
at
the
x
value
equals to
cancels, right?
yes, because there's a common factor. So when you
Right.
have a rational function and it looks like the restriction is there because the denominator shows a 0, then it is just possible that there could be a whole. So you have to look
Yeah.
for it. Is it okay? So
Yes,
this
sir.
is one of the indeterminate forms. And if that happens, you have to apply one of the 3 strategies. First
Yeah.
one, of course, is factoring. Okay, so let's get back to our questions.
Yeah.
Here is question number 2 for you.
Yes, sir.
How will you answer this?
8x. Yeah. So x approaches half.
Yeah.
So once again, I would also plug in half and then
Correct.
evaluate for the limit.
You can plug in half, evaluate, what do you get?
Yeah.
So, okay, let us factor the denominator. Okay, so question 2. So let's factor the numerator and denominator. Can you factor the numerator? A cube minus
Yes, sir.
B cube. You know the formula?
Yes, sir. A minus B.
Let's write down. A minus B.
A squared plus AB.
Perfect. So let's
Yeah.
factor numerator and denominator. What do we get? So numerator, which is written as 8x cube, is actually 2x whole cube, right?
Yeah.
Minus 1. And the denominator is 6x squared minus 5x plus 1. So you're looking for 6 times 1, which is 7. 6 times 1, which is 6.
Yeah.
And we need minus 5. That means minus 6 and plus 1, right?
Awesome. Yeah.
So we write this as 6 squared minus 6x plus x plus 1. Let's factor this. Numerator can now be written as 2x minus 1 times square of 2x, which is 4x squared, and then plus product of these two, which is 2x, plus square of 1. And here we have 6 is common, right? You could factor otherwise also. 6x is common. X minus 1 and minus is common, x minus 1. So you can now further factor, getting x minus 1 as a common factor in the denominator and 6x minus 1 as the other factor. So in the numerator, we have 2x minus 1 times 4x squared plus 2x plus 1. We're looking for a limit of this particular function as x approaches half. So if I put half, denominator is not 0, correct?
Yeah, it's not 0.
So we can directly substitute x equals to half in this equation and calculate, right? So 2 times half minus 1 times 4 times half squared plus 2 times half plus 1 divided by half minus 1 times 6 times half minus 1 and get the answer, right?
Yeah.
So that is how you're going to do and calculate and get the answer. Is that clear to you?
Yes, sir. Clear.
Perfect. So I'm clearing the screen. Let's do the next one, which is question number 3. Limit x approaches 2.
Right.
2 to the power minus 1 minus x to the power of minus 1 x minus 2. Now if I substitute 2, denominator is 0.
Yes, sir.
So how will you do this one?
Sir, I think this one will also give us an indeterminate form, 0/0, right?
0 over 0. So we need to factor, correct? So we could
Yeah.
actually simplify it. So we are looking into x approaches 2. And what do we have here? 1 over 2 minus 1 over x, which is like 2 to the power minus 1 is 1 over 2, right?
Right.
X
Right.
to the
Yeah.
power minus 1 is 1 over x. And we're dividing this by x minus 2. Let's simplify this. So we have limit x approaches 2, taking 2x as common denominator, right? We have x minus 2 in the numerator, and here we have x minus 2 in the denominator, right? So they will cancel.
Yeah.
Right? So we get the expression as limit x approaches 2 of 1 over 2x, correct?
Yeah.
And now when you substitute 2, you get 1 over 4 as your answer, correct?
Correct. Yeah. 1/4.
Yeah. So we'll clear this and move on to the next question, question number 4. Can you factor or simplify and then find the limit of question number 4?
Yes, sir. So off the top of my head, it also yields an indeterminate form.
So 0
0
over
over
0,
0.
correct. As soon as you plug in square root 3, square root 3 minus square root 3 is 0. Square root
Yeah.
3 square is 3. 3 minus 3 is also 0.
So 0.
So
Yeah.
what will you do? Tell me.
Sir, so I think you can, well, x minus root 3, right? And then x squared minus 3. So can you factor out the x, sir?
Yeah, so denominator can be factored. This is x squared minus, you can think about square root 3 square, right? So you can
Right.
factor
Yeah.
the denominator as x plus square root 3 times x minus square root 3, correct?
Square root 3. Yeah.
And they cancel, and you have now limit x approaches square root 3, and you have 1 over x plus square root 3, correct? And as soon
Yeah.
as you substitute, you get square root 3 plus square root 3, which is 1 over 2 square root 3, correct?
Yes, sir.
So that becomes the answer of question number 4. Clear?
Yeah.
Next
Clear.
question, please. How will you answer question number 5? Find the limit of this expression when x
Yes,
approaches
sir.
0.
So this is also an indeterminate form
Yes.
again.
Hmm.
So I think you would factor out the numerator so that it can
Okay.
cancel.
When it is a cubic equation like this, it is good practice to use substitution method. So let us
Yeah.
learn the substitution method. Have you learned substitution method?
Yes, sir. I'm pretty sure we've touched upon it briefly.
Okay, so let us substitute cube root of x plus 64 as, let us say, equal to p.
Yeah.
In that case, x plus 64 is equal to p cube, right?
Yeah,
And
that's
x
right.
will be equal to p cube minus 64. Is it okay? So
Yeah.
that is first part. Second is, when x approaches 0, what value does p approach? That is what you have to check. So you can see from this expression, when x approaches 0, p approaches what value? P approaches cube root of 64, right?
Yeah.
Which is what? P approaches cube root of 64 is 4, right?
4. Yeah.
So we can rewrite this particular question. So question 5 can now be written as p minus 4, because p is cube root of x plus 64, and the denominator x is p cube minus 64. And then we have a limit, which is limit p approaches 4, correct? You can clearly see it is an indeterminate form. As soon as I put 4 for p, 0 over 0 is the result, right?
Yeah.
But now we have a cube in difference of cube in the denominator, which can be factored, correct?
Yes, sir. It can be
So it'll
factored.
be p minus 4 times p square plus 4p plus 4 square, which is 16. And they cancel. And therefore, we have this as equals to limit p approaching 4, 1 over p square plus 4p plus 16. Substituting p as 4, what do we get? We get 16 plus 16 plus 16, right?
Yes, sir.
1 over 48, and that is the answer. Is that clear to you?
So it's a very small value, right, sir? That the
Yeah,
limit
it is a
approaches.
small value. However, we use the method of substitution. That is kind
Yeah.
of important. Okay?
Yes, sir.
Can you tell me how will you answer question number 6? Absolute value x plus 4 divided by x plus 4 when x approaches limit, when x approaches minus 4.
Yes, sir. So once again, I think it's indeterminate. So
Yes.
I think this time, since it's absolute value, will we also go ahead with substitution?
We should actually write this as a piecewise function, right? So
Right.
absolute value of x plus 4 is going to be positive when you are on the right side of minus 4, right? So it should be written
Right.
as x plus 4 over x plus 4 when x is greater than equal to 4, right?
Yeah.
I should say minus 4, because at minus 4 it is 0.
Right.
However, it will be negative of x plus 4 over x plus 4 when x is less than minus 4, correct?
-4. Yeah.
So I could write this question as limit x approaches minus 4 of, this is plus 1 and this is minus 1. Do you see that?
Yeah.
So at minus 4, we want to find limit. So what is the limit at minus 4?
So there are two values, right, sir, for the limit of -4?
Yes, so the limit does not exist, right? So
Yeah.
at minus 4, we find that the value is plus 1 from the right side, correct?
Yeah.
And minus 1 from the left side. Now we are including minus 4 in the right side portion, right? So at minus 4, there is a dump discontinuity, right?
Yes, sir.
And clearly we can see limit does not exist, right?
Yeah.
Very important. So that part is clear to us. Let's move forward and take up question number 7. Can you answer question number 7, which is limit x approaches 1, x to the power of 4 minus 1 over x minus 1.
Yes,
So
sir.
this is again 0 over 0, right?
Yes, sir. 0 over 0.
So what will you do?
So I think we've covered so far the factoring method and
Yes.
the substitution method so far, right?
Yeah.
So I think once again you can apply the factoring here, right, for the numerator.
Correct. So x to the power of 4 minus 1. First, you could write this as x squared plus 1 times x squared minus 1, right?
-1. Yeah.
And then we'll further factor later, right? So we'll do
Yeah.
this as x, do it in 2 steps.
Right.
X squared plus 1 cannot be further factored, but x squared minus 1 can be written as x plus 1 times x minus 1. And the denominator, we have x minus 1. So clearly, x minus 1 and x minus 1 cancel. And therefore,
Yeah.
we're left with limit x approaches 1, right? And we have in the numerator x squared plus 1 times x plus 1. Since the factor which was giving us 0 over 0 has cancelled, we can substitute 1 now, correct?
Yeah, we can.
So when you substitute 1, you get 1 plus 1 times 1 plus 1, which is 4, correct? So the limit of this function is 4.
Yeah.
So far clear, right?
Yeah, so far all clear, sir.
Question number 8. It is a very important question from test point of view.
Yeah.
We have limit x approaches infinitely large value, and the function is x squared plus x plus x. Number 8. So we have to find limit for x approaches minus infinity. And the question is square root of x squared plus x plus x. So as we decided, we should do rationalization, right?
Right.
We know this is an indeterminate because we have a result infinity minus infinity, so it is indeterminate.
Right.
So we'll do rationalization. So rationalization means multiply by its conjugate, which is x squared plus x minus
-x.
over square root of x squared plus x minus x. So what do you get? You get this as limit x approaches minus infinity. So this term becomes a square minus b square, right? So we get x squared plus x minus x.
X squared.
And in the denominator, we have square root of x squared plus x minus x. Now what am I going to do?
Sir?
What I showed you. I'll factor out x squared from the denominator. You see that? I have x squared in the numerator. X and x minus cancel away. Here, I am factoring out x squared. So I have 1 plus 1 over x minus x, correct?
Oh, okay. Yeah.
In fact, I should write limit here as we go, x approaches minus infinity, correct? So let's rewrite. So we have limit x approaches minus infinity. It's a very important question from test point of view.
Yeah, it looks very
And
complicated. Yeah.
here we have absolute value of x, and within square root, we have 1 plus 0, right? Because 1 plus 1 over x is 0, right?
0. Yeah.
So we have limit x approaches minus infinity, and we have x squared over absolute value of x minus x.
Minus x.
Now, when you are approaching, so absolute value of x minus x means when you are approaching negative infinity, in that case, what happens?
In that case, sir, it would be minus x, right, sir?
Correct. Minus x. And so we have minus x is minus 2x, right?
Yeah.
So basically, we have limit x approaches minus infinity, and here we have x squared over the denominator is minus 2x. I mean, still, it is infinitely large value. Is that clear
Right.
to you?
Yeah.
So when you approach minus infinity, it is approaching x, which is infinitely large value. Is that clear to you?
Yes, sir.
So this does not exist. Is that clear?
Yeah. So the limit doesn't exist, right, sir?
Limit doesn't.
Also, sir, quick question. When we were rationalizing, right, in the previous step,
Yeah.
I think it went away, sir.
Yeah. Let me just. I want to check something. I still think this answer is wrong.
For
Yeah.
for this one, Q8.
Yeah. So here is the solution. I did some mistake. I don't know what mistake I did.
Yeah, sir. I think you forgot to put the x squared cancelled out. That's what I was just going to point out.
Oh, x squared cancelled out, right?
Yeah,
Right.
yeah,
I cancelled
yeah,
out x. That was the problem.
Yeah.
That is why I was thinking, like, why x is not cancelling? I should have got minus half as my answer. You get my idea?
Yeah.
So that is why I thought, what mistake has happened? Okay, that is the right solution. You see that solution now?
Yes, sir.
Let's redo it. Yeah, x square cancelled out, and I had only one x there. So it will cancel and I'll get minus half.
Yeah. I was just going to point it out, but then it got
And
erased.
then I removed this thing. Yeah, good. You now will do it again. Don't worry. I knew we had done a mistake, but I couldn't catch it. Yeah, a square minus b square. I wrote x, and then I correct. Anyway. So, Akshat, here is question number 8 for you. Tell me, how will you do question number 8? It is limit x approaches minus infinity for square root of x square plus x plus x. Tell me, how will you do?
Sir, we can solve by rationalization.
Yes, we can. So, multiplying by what and dividing by what?
We can multiply by the conjugate, which is x squared plus x minus x, and then divide by the same.
Correct. So, what do you get now?
So now you get x squared plus x minus x squared over the same denominator.
So, this square minus x square over the denominator, which is square root of x square plus x minus x, right? So, simplify. What do you get in the numerator now?
Just x.
Just x. And the denominator, how will you simplify that?
We can take the absolute value of square root x squared.
Common, right? So within this, we are taking square. This is a very important step. So we get 1 plus 1 over x. X divided by x squared is 1 over x, right?
Right.
Minus x. So we have here limit x approaches minus infinity of x over. Now that is absolute value of x, correct? And we have x. Now, when x is approaching minus infinity, then absolute value of x is approaching minus x, correct?
Minus x, yeah.
So, and x is approaching minus x, correct?
Minus x too, yeah.
So in this particular case, when x is approaching negative infinity, and if I substitute in these values, I could write this as absolute value of x as minus x, right?
Yeah.
So we get minus half as our answer. You get the idea.
Yes, sir. X and
So
X
that
cancel, right?
x and x cancel. And that is how we get our solution for the given question number 8.
Yeah.
Okay. So when x approaches minus infinity, it results into minus half. Correct.
Yeah.
Now let's do question number 9, which is limit x approaches 3, and we have square root of 7 minus x minus 2 divided by 1 minus square root of 4 minus x. So what happens when
Yeah.
you substitute 3 here?
And the numerator it becomes 0, sir. And so does the denominator too. So you get indeterminate form again.
So when you substitute 3, which is 7 minus 3 square root is 2, 2 minus 2 is 0, and you have 1 minus 4 minus 3 square root, 1 minus 1 is 0, so you get 0 over 0, it is indeterminate. Now in this
Yeah.
case, how do you solve further?
Yeah. So I think we can let root of 7 minus x equal a value, right, sir? Like p, and then we can solve for it.
You could do that, yes. But then 4 minus x will be what? Slightly more complicated. You get the idea?
Oh, yeah, yeah.
Rationalize both numerator and denominator. So in such cases, rationalize both numerator and denominator. You get the idea?
Oh, okay.
So that means you multiply by the conjugate of the numerator, which is minus 7 minus x plus 2 over
Yeah.
square root of 7 minus x plus 2, and also the conjugate of denominator, which is 1 plus 4 minus x, 1 plus square root of 4 minus x. Does it make sense to you?
Yes, sir. Got it.
So rationalize both numerator and denominator. Okay, so what do you get after this?
You would get 7x minus 4 for the first part.
Yes, and then multiplied by 1 plus square root of 4 minus x, correct?
Yeah, correct.
Over 1 minus 4 minus x times square root of 7 minus x plus 2. Is it okay?
Yes, sir.
Correct. So simplify. So 7 minus x minus 4 is 7 minus 4 is 3, 3 minus x, right?
Yeah, 3 minus x.
That was the factor giving you 0, right? 3 minus x?
Yeah.
Right? And
Correct.
then multiplied by 1 plus square root of 4 minus x divided by, here also, 1 minus 4 minus x. 1 minus 4 is minus 3, right? So you get x minus 3 here. You see that?
Yes, sir.
So it's square root of 7 minus x plus 2. So when you cancel, you get a negative term. You realize?
Right. Yeah, negative numerator.
Yeah. So we have limit. We can take negative outside.
Okay, yeah.
We'll see later. So we have 1 plus square root of 4 minus x over square root of 7 minus x plus 2. Now substitute 3. So negative outside, substitute 3. 1 plus 4 minus 3, right? Over 7 minus 3 plus 2, correct?
Correct.
So which is what? Negative of 1 plus 1, right?
Yeah.
And denominator is 7 minus 3, 4, 4, 2 plus 2, correct? You get
Correct.
negative 2 over 4, which is negative half.
Okay.
That is how you're going to solve this question. So it's kind of tricky, slightly long, but
Yeah.
to get radicals in both numerator and denominator, you need to rationalize both numerator and denominator, just as we have done. Clear?
So substitution wouldn't be a good method here, right, sir?
Very complicated. It could be. You could try by substitution. Not a bad idea. Try by substitution, okay?
Okay.
So we can try. So let's substitute, right?
Yeah.
What will you substitute? Let's say square root 7 minus x is equal to p. This is what you want to substitute, right?
Yes, sir.
So two things. What will be 4 minus x? This is what you have to figure out, right? So we'll
Yeah.
square this. And so it becomes complicated because when you square this, you get 7 minus x is equals to p square, right?
Yeah.
So you want to get 4 minus x. So you'll add, subtract 3 from both the sides, right? So you get 4 minus x is equals to p square minus 3. Is it okay?
Yes, sir.
And square root of 4 minus x will be square root of p square minus 3. You see, it is getting kind
Yeah.
of complicated.
Right. Yeah.
So let's not do it. That's what I've tried
Yeah.
to say. So don't do substitution. Do rationalization. Easy.
Yes, sir.
Last question here. Question number 10. Square root
Yeah.
of x minus 1 over cube root of x minus 1 limit x approaches 1. So as soon as I substitute 1, I get 0 over 0. So it is
Yeah.
indeterminate. Now, you could rationalize, you could factor,
Yeah.
and solve. What will you do? Or you could substitute. You want to do
Yeah.
substitution? Let's do substitution. We didn't do so far, right? So
Yeah.
let's substitute cube root of x as equal to p, right?
Yes, sir.
So x will be p cube. And
Right.
now, when limit x approaches 1, then limit p approaches 1
1,
cube,
2.
which is 1, right? P also approaches.
Yeah.
So you can rewrite the equation as limit p approaches 1, and this becomes, okay, we are saying x is p cube, right?
Yeah.
And so cube root. So x will be p cube, right? So square root x. This is square root x. How will you write?
Yeah. So,
Two to the power of
sir,
3,
would it,
right?
yeah.
Slightly
Yes, sir.
complicated.
Yeah.
How will you factor?
Sir,
So
initially I was thinking,
yeah,
initially I was thinking that since it's square root x, right? So we can just do squared p cube, but I don't think that will work out, right?
pardon?
Since in the numerator, so there's square root x, and we wrote x equals to p cube. I was thinking that we can simply write square root of p cube, but will that work out that way?
Okay. So actually, what you could do here is that if I say square root of x is, see, basically one is x to the power of half. The other one is x to the power of 1 over 3. Do you see that part?
Yes.
That is the problem. So what we should do is, instead of doing, because we should have a common denominator now,
Yeah.
then we could actually work on this rational exponents, because this is half and 1 over 3.
Yeah.
So 1 over 6 could be a good option
Yeah. As an exponent. Yeah.
as an exponent. So instead of substituting cube root of p as cube root of x as p, sixth root of x as p, we could have been a better option.
Yeah, we could do that. Yeah.
That is a better. So we will not do this, and instead we'll substitute sixth root of x as p. Is it okay?
Yes, sir.
In that case, the third root, cube root is p square, right? And the
Yes.
square root is p cube. You understand now?
Yeah, got it.
So that is the substitution which we are going. And still, as x approaches 1, p approaches 1. Correct? So now
Yeah.
we have our equation. Instead of square root x, I'll write p cube minus 1.
Minus
And
1.
here, I'll write p square minus 1. Now do you get it?
Yes, sir.
Now it is
Sir?
simpler. So this is a very tough question actually.
Yeah. Sir, quick question.
Yes?
So when we take the sixth root of x, right, that equals to p,
Yeah.
and then how did we go from that to the cube root of x equals p squared? You just squared the thing, right?
X is equals to p to the power of 6, correct?
Yeah.
So as soon as you do half of this, then you have to do half of this.
Oh, okay, okay. Yeah, yeah.
If
Yeah,
you
yeah.
do 1/3, then it is p squared, correct?
Yeah.
That is how
Correct.
you do.
Got
So
it.
now p cube minus 1, is p minus 1 times p squared plus p plus 1, correct?
Plus 1.
And
Yeah.
p square minus 1 is p minus 1 times p plus
P
1.
plus 1.
And
Oh, okay,
now
wow.
you
They
can
cancel.
cancel these and substitute 1. and you get 1 plus 1 plus 1 over 1 plus 1, which is 3 over 2. Do you
Yeah.
see this part? So this
Yeah.
is very tough question from examination point of view, and that is how you're going to do it.
Yeah, sir. Wow. I never would have thought of it that way.
So sometimes,
Yeah.
just as solving rational expressions, you take a common denominator. So while you're substituting, look for that common denominator.
Yeah. Yeah.
Good. Correct. So now that brings us to question number 11. Now, normally you do not study this, but let me share with you. We started with this. Like, what is the limit when x approaches 0 for sine x over x?
Yeah.
It is 1, right?
Right.
Always
Yeah.
x is measured in radians. X is in radians,
Okay. X is in radians, not degrees, right, sir?
not degree. So when x
Yeah.
is in radians, sine x over x, limit x approaches 0 is 1.
Yeah.
Using this concept, we can actually find the solution of question number 11, right?
Yeah.
So we have limit x approaches 0, but we have sine ax
Yeah.
over sine bx. What will that be equal to? That is the question.
Yeah.
So what we can do here is that sine ax and sine bx. So we can multiply and divide by ax.
Yeah.
So
We
get
can.
this
Yeah.
form. Do you understand?
Yeah.
So we can rewrite this as limit x approaches 0, and we have sine ax. We can multiply this term by ax over ax, right?
To get rid of the AX, right?
Yeah, so that we have one term as sine x over ax.
Yeah.
It will be 1. And then x is approaching 0. We can still work with it, right? And the
Right.
other term also will multiply and divide by bx. Is that okay?
Yes, sir.
Correct?
Correct.
Now I could rearrange this and write this as limit sine ax over ax. So taking care of these two, and this I'm multiplying by ax separately. Do you see that? But I could
Yes,
cancel
sir.
ax. I'll cancel it now, where x is
Okay.
approaching 0. And denominator, I could write this as sine bx over bx,
Over
correct?
BX. Yeah. Times BX.
Now x and x cancel here, correct?
Correct. Yeah.
And you have limit sine ax over ax, which is how much? Which is 1.
Yeah.
Because ax could be treated, let ax be theta, for example, right? Theta over
Yeah.
theta will be 1, right? So
1. Yeah.
so we have this as limit sine ax over ax, x approaching 0, over limit x approaching 0 of sine bx over bx. These are the properties of limits. So
Yeah.
limits in parts can be added and all these operations can be performed. And we have a constant here, a over b. Do you see that?
Yeah.
Both the limits sine ax over ax and sine bx over bx, when x approaches 0, is 1. And therefore, the answer is a. I should write a is, yeah, a over b, right? Do you see that? So we
Yes,
get
sir.
the answer as a over b for this particular question. Does make sense to you?
Yes, sir. Makes sense.
Okay. So with that, we come to the last question, which is sine of cos x and cos of sine x. I'll leave this
Yeah.
as an extended question for you. You need to do
Yes,
some
sir.
research and then find how could it be solved. Is it okay?
Yes, sir. Sir, quick question. For that one, we would also go with sine x over x as one of the main
Yeah, but this
constituents,
is
right?
sine x cos x. So you could do, let's try. What you could do is you could substitute. So we did these 11 questions. Strategies learned are, if you get an indeterminate, then what should you do? I like you to revise these things and make a short note on that. So what did you learn
Yes, sir.
in solving these questions today?
Sir, so before in our last class, when we discussed indeterminate forms, I was still very new to the whole form of limits and everything. But now it's more solidified that we can either use substitution, we can factor the numerator or denominator, and upon proper cancellation, then we can find a new limit, or even rationalize. And today I was also introduced to rationalizing both the numerator and the denominator, which I didn't know was possible. So yeah, I think all those tactics together have helped me understand the concept of limits better.
That's great. So, Akshat, we'll end the class here. Try the last question, and
Yeah.
then we'll move forward from here look into the next chapter, which is actually derivatives.
Yeah,
Or we will
sure.
do continuity of functions using limits. That is our next chapter. We'll do that next.
Okay.
Is it okay?
Yeah.
Great then.
Yeah.
See you then. All the best.
Thank you, sir.
Thank you.
Bye.